Welcome, everybody, to the next episode of our podcast, Coffee Breakdown. I'm Aaron Ho, and today our guest is Daan van Vugt. He's the founder of Ignition Computing and a fellow fusion enthusiast himself. So, welcome to the podcast, Dan.
Thanks, Aaron. I'm happy to be here.
Yeah, so that is one thing I definitely wanted to bring you on to discuss is actually Ignition Computing, so far as I understand, is a startup that you founded. And just tell me a bit more about it, like why you decided to start it, what it's about.
Oh yeah, sure. Um, so Ignition Computing, the name betrays it a little bit, is about computing more or less to help fusion. At least this is the original idea which kind of started when I was doing my PhD at ITER. Um, I was doing a lot of computational work there on a very complicated MHD code called Jurek, and was having a lot of fun writing these extensions, doing new science there. Um, but I found that I was enjoying much more writing than writing code than writing papers, and um, so started thinking how can I get myself in the position to keep doing that while helping the field. As maybe some of you know, it's there's not so many positions for support. There's many more researcher positions in this field. And I noticed that at ITER, a lot of the development was done by scientists or by companies who have not so much experience in fusion. And so I figured, hey, maybe we can do something here. So a plan was born to try and help do some of the development for ITER and maybe later also for other fusion startups. And yeah, so far this has been going quite well. I think we've gotten some contracts, we've built some stuff, and I I think we'll continue much more because yeah, as you may know, at ITER we're working really to build the machine, to get this first iteration off the ground, to build this, get this first plasma, and so much effort is going into this that there's not really enough time to finish the software that goes with it. So we'll have a very big and expensive and complicated machine that we cannot really drive to the limits because we don't know where they are and we don't know how to get there. And
That's
so
a,
yeah.
I think that's a very good point that you bring up there, right? I mean, in my experience as well, we've seen that there's a lot of scientists trying to build this software, this code on their own, but it's not their primary, job or interest or even their primary strength, even, right? And so we end up with these like cobbled together codes that they serve the purpose, they do their job, but they are hard to maintain, they're hard to adapt for new situations, all this sort of stuff. And yes, there's been a lot of, let's say, outcry for professional support, the software support on these sorts of things. So I really like that you took this into your own hands, feel like, like we need this and I want to make this, right? Yeah,
Yeah,
that's really cool.
yeah,
So
and I hope we can keep doing this in a bigger form because uh, ITER is a bit of a special case and that they have a significant budget and that they have some of it for software development. But actually, if you look at the other research budgets, there's very little support allocated. Maybe you have an experimental budget, but if you are a computational scientist, then typically all you get is computing time, and you have to figure it out yourself. And
mm,
so that's one of the things I hope that we can change in the funding landscape in the near future, so that we can help out some more scientists.
yeah, that's definitely needed. And in a sense, then maybe we can get into it is also like your experience starting up a startup on its own, like going from the research field, being a scientist in academia, and then starting your own business. I also understand that this is not your first foray into startups, but it is the one you are known for now. So tell me a bit about that experience as well.
Yeah, so there's two things I would highlight. First is that as a scientist, you're not that far from being an entrepreneur. If you look at the parallels, really, as a you're responsible for bringing in your own money. So you have to do sales more or less.
Mhm.
If you get to the group lead stage, you're managing a team. You your output or your sales is in papers and in um, reputation. You're more or less self-dependent. Nobody is really telling you what to do. Uh, There's there's a lot of parallels, and um, yeah, I think there's so much similarity, except that you don't have to do all of the boring tech stuff and wage.
So yeah, so I agree with you that many of the aspects are similar in that way. So I guess what you're saying is that it's not that large of a jump
Yeah,
going from
exactly,
academia to starting your own
exactly.
business.
And,
But
and
I'm
for me,
sure there
yeah.
are small details, as you mentioned, like taxes and maybe like found setting up the administrative part that is a
Oh
bit,
yeah, yeah. And
right?
the sales is very different, right? And
Hmm.
like there's less grant writing and more smaller sales, or the cycles are a bit faster. And well, for me, I was a bit fortunate in that I've had like what do you call this, solo entrepreneurship, like ZZP, a one-man company
Ah,
for a long time, actually since I was 18 or something, doing web development on the side. I figured it's better than stacking shelves somewhere, and and yeah, this gave me some experience on how to set up the practical side, like um, taxes, incorporation, but also how to what works and what doesn't in regard to sales a little bit. And so it
hmm.
was quite a natural choice. And I've we've tried a few things during and after the PhD, not all of which worked out. Some are still alive, but not very active, and some we have had to kill. Um, and so now what we're doing most is like is ignition computing and my other company after service. And yeah, it's it's really interesting, but the difference from going to from the PhD to this is not as large as you would expect.
Hmm, that's very interesting. So I guess that a lot of the skills that you learn in the PhD transfer very well. So especially for someone like you who just you see a let's say an opportunity in the market or a lack, a gap
Mm.
in the knowledge, and you want to fill it. Especially as you say, support is not sort of what do you call it a extremely high priority in science at the moment, or at least in academia at the moment. So going and founding your own business to provide it is was sort of the natural solution, I guess,
Yeah,
to solving it.
and
Mhm.
I saw these other um, I saw these tools being produced at ITER as part of development contracts, where I get the feeling like, hey, we can do this. We could build this, and I would do it in a different way. And
Mm.
so um, now we are doing a few, and I hope we can do many more soon. And yeah,
So what is this different way? I guess this is a good point to segue into this part where your experience in the field, I suppose, doing software development and also not just for yourself and for businesses, but also for the scientific field,
Mhm.
it gives you a different kind of oversight on what software should be or how it should be developed. And maybe we can discuss that a little bit
Yeah,
because myself, I work in software development, but on the academia side. So this would be interesting for me to know as well.
yeah. I think it depends which field you're in academia. Like Fusion is known for massive collections of legacy Fortran codes, which are very good still, so hard to replace, and a whole bunch of tools which are kind of located with a research group. Whereas if you look at say web development or deep learning or any of these fields, a lot more of the stuff is really open source, and a lot more packages build on each other. There's more interaction there, which the community is much larger, of course, but it's something that I think we could learn from in Fusion as well. And there's a few obstacles. For one, for instance, for ITER, all that everything they produce has to be available to ITER members only, and this means that it's not really easy to open source. But we're working on this for some of the projects that we've developed there. Um, and it's just a different mentality or a different outlook. Um, like, have you heard of not invented here syndrome?
Oh yeah, absolutely. I've been almost a victim to these sorts of things too. So yes, yeah.
Like I used to think that building your own solution typically is more fun and you learn stuff, but now we're trying to reuse as much as possible, and um, there's a trade-off there because your dependencies have to be stable enough or maintainable enough that you don't paint yourself into a corner, or you're not stuck in 10 years from now when these Fortran codes will still work and your your SciPy and whatever contraption will not. Um, but I feel that for many people in the Fusion community, it's gone kind of the other way, and a lot of things are um, not openly reused, or maybe not. Um, yeah.
Well, one of the bigger problems in that is something that I've recently learned how to do throughout my PhD, but was definitely not in my skill set when I started. Was like proper version control,
Oh yeah.
right? This is something that in academic field is hard to implement. Now there are tools, very convenient tools, but I still had to learn them, like Git, right? Like the
Yeah. Yeah.
fundamental, or SVN if some people use it. But these things are not standard in terms of like the skill set of an academic, and they are
Well, they should be.
extremely, they should be correct, perhaps, especially if you're working with software and
I, I
software development.
I think it's getting better now. So most of the classes I've seen now teach this. So at
Hmm.
least the fresh master students should know. And so maybe we've passed the problem now, but there's still a lot of people who don't know this or who don't use this properly.
Yeah, but it has enabled like even my knowledge in it, and it is slowly spreading, but it has enabled faster development, and less, let's say, uh, stigma against having other people work on projects that you're developing,
Oh yeah.
because you suddenly have more tracking of
Mhm.
who's actually doing what and what they contributed to the code. It's not like they change a line and suddenly it's changed and you have no idea what changed or how, right? So that
It's true. Yeah.
removes some of the stigma of people who like want control over their code or over their software.
Yeah.
It allows them to collaborate a lot more.
And I think it's a nice topic to get a little further into, because the real question that we've been asking ourselves at the Dutch Federation for Research Software Engineers, or we're hosting a meetup on that soon, is how open source should our research software be? Because
Hmm.
there's a few reasons that you would want this for the community, but there's a few reasons also for you personally, and there's a few possible drawbacks. And one of them is indeed, what if they break stuff?
Hmm.
Then of course with version control and with some proper automated integration testing, you're more or less protected against that. But there's a whole bunch of other reasons why maybe you keep some stuff hidden. Like this code that I worked on, Jurek, um, I think there's like 60 to 100 people or so who have access, and
Wow.
that's all. And there's reasons for that, like reputational reasons, and you can get access, but it's not that like you go on GitHub and you clone a project. And
But still, 60 to 100 is still a lot of people working on a single code, right? I mean,
yeah, yeah, so this group has grown quite a lot in the last few years, and not everyone is developing as
hmm.
intensely. Like typically, you have a few core contributors who do most of the work, and then there's many people who are using it and adapting it slightly and fixing small bugs they encounter, etc.
Okay. So it's still like it's the larger community of users than developers in that 60 to 100.
Yeah, you don't have to split them out so much. I
Hmm.
think um, especially for us, for scientists, it's very easy to make small, to understand what the code is doing and to suggest small fixes. And um, I'm personally not really a fan of this user developer divide. Like
Okay.
it makes sense if you're deploying an application somewhere, or if you're hosting a web server or whatever. But if you're providing a very complex computational tool, which is typically used in concert with other tools, and uh, you yeah, you should expect a little bit more knowledge from whoever runs it, and more yeah, work or contributing back also.
Hmm. I see. So in some sense that the user eventually does transition to at least a minor developer. Like they
Yeah,
contribute bits here and there. And so you're saying it doesn't make sense to really think of people as users and developers, more
it's yeah,
just
it's like in
people
the
working on the code.
it, yeah, people like there's more you can do to contribute than just writing new lines, right? You could write documentation, you could file bug reports, and I think we can learn from the open source community on how to do this, how to get people to have a nice onboarding path to contribute, even if you're not in a specific group.
Yeah,
So like,
so there is one question, right? Also the amount of overhead needed to, to organize this. You need some core members whose, I guess, core function
yeah,
is to oversee all the different people who are using it and all the issues that they're coming up with, and
mhm,
actually coordinating the resolution of these
yeah,
issues, right? Like which ones are more important, which ones are less, and divvy the resources. Is there an issue, like, because that overhead sometimes it's usually a scientist who has to do that. Sometimes that's not their primary
mhm.
function, like they would prefer to do their own research rather than
I
oversee
think
the
yeah,
code.
yeah, you're exactly right. I think this is one of the reasons that a lot of stuff is hidden
Mm,
or not public, and it's also that you because you don't really get a lot of recognition for doing it. People who use the code, maybe they cite your paper, and maybe they know who the maintainer is, but
mhm.
probably not. And in your funding applications, it doesn't really figure in too much yet.
Yeah, I guess in terms of amount of time spent versus amount of return that you get from the community
Yeah.
is a bit uh, unbalanced at the moment. But do you think there's a way to change that, right? Like, because it's going to be, if we want to move in that direction,
Mhm.
how do you foresee that we could tip the balance back?
Yeah, so I hope there would be an option to allocate budget to either contribute directly to your code to the community to get some return on that, or alternatively to be able to reward maintainers for their role in the community. So that, like, imagine you get a maybe you get a grant from NWO, and uh, part of the grant is like a 2% uh, infrastructure budget or whatever that you could use to Patreon or whatever to maintain some of the libraries which you are using and which are really helping you.
Hmm.
Because we have to realize that you're getting it for free now, but the only reason you get it for free is because someone has made it. And if you want to keep enjoying these updates, maybe it's good to support the people who are making this.
Yeah, that's a good point, right? I mean, I don't know if I fully endorse sort of like a subscription, at least in science, a subscription
Mhm.
based thing. But I don't know. There should be a way to return to the person who makes and maintains these codes
Yeah.
in some meaningful fashion. Though I guess some people have built their careers on having a code. They if it becomes so big that it is,
Mhm.
you know it's an essential piece of the toolkit, like there was no way that anyone would let it fall to the side. In some sense, being the one who knows the most about it is some form of job security or some form of career security.
Exactly.
um, but I think that's the only avenue of return that exists at the moment, and like not all codes make it to that level, right?
No,
of
I think
prestige.
most don't actually,
Yeah.
but you're right. It can help with getting your name out there as a junior scientist, which I think is one of the most important things, and one of the things that we more or less forget during the PhD. We all
Hmm.
have this tendency to um, work, and to solve really difficult problems, and then maybe eventually you realize, oh yeah, we should tell as many people as possible about it. But um, this is really the first thing that you should do. And it's yeah, because your career depends on your connections there, and on how you um, well, you'll find your postdoc most probably through someone that knows you or your work. And
Mhm.
uh, the best way to get people to know you or your work is to share it with them. And so I think on a personal level, it can be very um, productive to make something useful and to give it away. And
Mhm.
um, eventually, you can get job security out of this. Maybe if it becomes important enough, and you are the obvious maintainer, that it makes sense to include you in all kinds of future projects because the functionality is necessary.
Right. And I think that's true. I think I've spoken to other, PhD students who have developed either modifications to codes or a code of their own. And I have asked them to, would they consider open sourcing it? And it's always some sort of pushback on it, right? Like, because it is a fair amount of work. Like I've open sourced a fair amount of my developments, and I understand it now. It is a fair amount of work, because it needs to be somewhat professionally written. It needs to it needs to work and
Yeah,
smoothly. If other people use it, then they're going to release like issues or send you emails like this doesn't work in this particular case. Could you fix it? And so it is a lot of maintenance time. I can see why someone in the middle of their PhD probably doesn't want that extra burden
oh
on
yeah,
them. But is there like, but it is valuable to do it, right? In
I
the
think so.
end.
And I think in many cases you may not even get away with not releasing your code eventually, because it's going to become a requirement for many journals to publish what your inputs to your work.
Mhm.
It's it's slowly moving in this direction at least.
And I
Um,
think I think the message, I guess, or at least the question I have to you is, if you were to sort of ask people to open source the codes they've developed, is there a strategy that you um, recommend, right, or a way to do it that you recommend that is sort of reasonable both on getting an open source code at the end, but also on the person who is doing the open sourcing, like doing the code development?
that's why I don't know. I think it's a decision that you as a maintainer should make um, out of your own conviction. So I guess it would make sense to explain why it's very helpful to others and to the community if we could all do this. But this is a very um, general argument, and it's much better to focus on the specifics of, say, hey, this could get you hired somewhere. Like
Hmm.
most of us after a PhD will not find a postdoc because there is like a factor 10 less postdoc, fewer postdocs than PhD positions or something. Um,
Yeah,
I'm not sure if it's factor 10, maybe it's 5, but
it's
still.
less for sure.
um, but still, and then it's very good if you can actually show something you've worked on, or if you uh, get some connections. Um, so it could help on a personal level also. But I think
Mhm.
we have to slowly go there, and there's other fields where this tendency is much stronger, where it's much more developed. I think here in the fusion field uh, there's a few, let's say, competitive groups which have uh, their own code as sort of their competitive advantage also. So you don't want this to spread too far, and um, it's a race, and it's also fun. It's
Mm.
also a way to get people to get the best out of their research, to work hard. But um, I think well, not that I know too much about some of the other research fields, but I have the feeling that it's much better there.
In the other fields than in
Yeah, yeah,
fusion.
yeah.
Okay. In what sense could you say, in terms of like the reward that you get out of it, or
Oh,
in?
just in which tools I've encountered. Like
I see.
never now and then you find some tools to solve a problem that you have, and then this comes from, for instance, it comes from bioinformatics. These guys release a lot of stuff, and then uh, for me, that's kind of a sign like, hey, they're open sourcing much more stuff, because how often do I encounter like a workflow management engine or whatever uh, from the Fusion field?
I see. So I see your point. But there's also, I guess we can move into the next part, which might be interesting for people who want to open source their codes, is how to, I guess, in a way, protect themselves, right? This licensing issue. Most open source codes now have some sort of like open source license,
Yeah.
but there are different types of them, and depending on, how exactly open you want it to be, you can pick different ones. And I think that a lot of people are also just ignorant on what options they have, and thus comes a bit of pushback on that as well. So maybe you can explain a bit, if you
Oh,
wish.
I have some idea there, but I'm not an expert on all kinds of licenses. But there's basically two big groups. You have the copyleft licenses, which are like the GPL, which ensure that any copy that people make is also covered with the same license, and are kind of lock this code into being open source forever.
Mhm.
Um, and then there are the freer licenses like MIT, BSD, Apache, which basically say, here's the code, but use it at your own risk and have fun. Um, those are much more compatible or easy to use for other organizations, because they can modify it and keep it inside their own organization, whereas the copyleft licenses, you have to contribute back, basically.
I see. Okay.
So
So it
that's the main split, and then there's different versions, different variants. Um, there's some good websites that explain this. There's like license picker websites. So I would recommend to take this, or to look at another package that you use where you know that they thought about it.
So maybe please send the link if you haven't already, and I'll put it into the description of this podcast episode. I
All
think
right.
that those who are interested can have a look on their own. Then let's shift into the more technical aspects. So we've covered more or less the administrative part, right? Like open sourcing a code, what it would require of you as a person. But there's also the other side of computing which you deal with, which is like the technical part of computing. Obviously, a lot of codes that get produced from the academic world are not, you know, that high in terms of computer science, right? Like in terms of parallelization, or in terms of just being compatible with different architectures, all this sort of stuff. Do you see that as something that an academic field or an academic person should handle, or is that what the support like companies like you, Ignition Computing, are for in a way?
I think this is firmly a support role, and
Hmm.
it doesn't have to be an external company even. There are institutes which have computing support staff, and depending on the skills there, you can get quite far. For the bigger institutes, this works. Um, but really, you have an expert in, I don't know, gyrokinetics, and you're asking them to figure out the fastest way to run something on the GPU. It's a very different skill set, and you can possibly you'll learn a lot as a PhD student in that case, but you can also waste a lot of time. So
Absolutely, especially when you're being graded on the physics, right, rather than
exactly,
the code
and only the
acceleration.
physics.
Yeah, yeah.
And so there's a few forces at play here. One is that you're not really um, paying for your computing time. Typically, some research group will get a big allocation of say 1 million hours or something, and take the year to spend this, and then typically they don't completely spend it, or you go over budget, and it's um, maybe there's a little stress then, and it's very insulated. Like, I think it's quite easy as a PhD student to spend more in compute costs than in salary costs. So um, you don't notice this, and that means that there's not so much an incentive, except for not wanting to wait, to really optimize, which is
Hmm.
fine. I mean, you're optimizing for time to results, not computing time.
Hmm.
But as if we want to some electricity and we want to save some time and some money, then maybe it makes sense to have people available for help, or to build little shared bits of infrastructure. And yeah, I think we can do better there. Like if you have an experiment, then also you have technicians to help there, and there are a whole bunch of tasks that you wouldn't put you and your people in charge of.
That's true. I think that there is a role for having this type of support available. I there is a question of, how most institutes, at least that I know of, or universities even, don't really invest in that type of support. So it would take, I guess, a particularly insightful PI, principal investigator, to actually then engage in getting that support for their team or for their code or something like this. Is, I guess, that in that sense, is there a lot available out there
Well,
from your
so
experience?
in Fusion, there this is improving, right? So you have the Eurofusion Advanced Computing Hub, for instance,
Mhm.
that you can talk to, and then um, these are supporting the TSVV groups. Um, Besides that, I haven't seen this so much.
Mhm.
Um, like actually, if we go the other way around, at the during my PhD, I was supporting some people just because it's fun to solve some of these problems for them. But
Right.
um, I think it's getting better, but I think we have a long way to go.
Okay. I would say, yeah. So in terms of, I guess, in your opinion, what type of tasks would be best suited for support? Because I think a lot of people aren't, at least in academics, aren't capable of separating, what is sort of the things we need to do just to get the task done, right? Just to
Mhm.
look at the physics, and the things that could possibly be given to a support team. And
Yeah.
without knowledge of where to draw the line, everything just gets placed into, well, we'll handle it kind of
Yeah.
problem,
Yeah.
right?
I would start, like, imagine it's more or less a new project. I would start with a little with a an infrastructure discussion, and maybe just some knowledge sharing on what is already there, because it can be quite hard to find which tools exist, which tools would solve most of your problem, or how to build your data sets. Uh, so maybe just a few discussions, and then maybe some specific projects roll out. Like you don't want to take away all of the work there, because you know it's research. You don't know what the necessary architecture will be.
Right.
You- But maybe you can make a guess together and see if we can reuse something from something which is known already in the institute. And this knowledge is also kind of fleeting. Like as I mentioned, like Fortran solver files floating around. I have some file from 1970 in my code base somewhere, and I think everybody copies this. And I know inside differ also there are some remnants of some nag stuff, maybe
Yeah. Old libraries
old
for
libraries everywhere. and
yeah.
and so if you know that these exist, as a like the PI is probably the person who has found this, but maybe they don't even have the biggest overview yet.
Yeah, especially when it comes to the availability of software out there. It's a completely new world. Sometimes it's really like learning a foreign language, in my opinion. It's
Yeah.
There's lots of stuff out there, different acronyms and different names, new terminology. It's really hard to navigate if you're not
Mhm.
already yourself
Yeah.
knowledgeable, right? So I guess in that sense, having someone around who is well versed in that world is already very helpful, even if they're not the ones that will end up doing it for you. But
Yeah.
at least someone to help navigate that is useful. But
Yeah,
I think,
and to give you some keywords to point you in the right direction, like, hey, oh, I want to do this. Well, you should try SciPy, or you should try Julia, or you should this guy has done something like that in the past. Talk to him. That kind of role, as slightly broader information sharing than just a single PI can do, I think could be useful. And then, yeah, the second rule is to, if you have specific uh, parts which are reused between researches, to write these properly. And so this is stuff um, like Karel van der Plas is doing a lot,
Mhm.
is writing infrastructure. But he's a PhD student, and all the time he spends writing infrastructure, he's not spending writing papers. So
Right.
there's actually a personal cost to that.
And I think that that's one of the biggest dilemmas for someone who's doing computational as things inside academia, especially if you're a PhD student, is that how much time do you spend improving the code base and how much time do you spend analyzing results from the
Yeah,
code base, right?
yeah. So I was firmly on the time of on the side of spending too much time writing, and um, managed to get a few papers out, but most of the result of my PhD was just new code, and
Mhm.
luckily people are using this now to bring more science, and it has helped make a bit of a reputation. But besides that, if I wanted to go for academic achievement, I should have written less.
Hmm. Yeah, that's a big question. That is the big question. It's really interesting in that point of view that it is necessary. As you said, the stuff you developed is helping to accelerate scientists who are coming after you, let's say,
Mhm.
who are using the code after you've made your contribution. But in some weird way, I mean, I don't know if this is true or not, but in some weird way, you're not getting, let's say, the credit for it either, because it's part of a bigger code and someone else is in charge of it. So in some sense, you could also see it as a bit of a, a bad career move to be contributing to someone else's code. And some people do see it that way, and that's unfortunate in my opinion.
Well, I agree a little bit there, though. It's imagine you're working with a big code and you're contributing a significant part. Then, um, of course, it will help show that you know what you're doing, and it may help you get postdocs inside of this group. But if you wish to move outside of it, and um, all that happens is that maybe on the next group paper your name moved from seventh to fourth, it's not helping you a lot. And
Mhm.
so it's it's good to have more or less compartmentalized projects that you could maybe, yeah, put your name on or something, or to have something that you could point to that is really separate and yours, to make it simple to show your achievements. And of course, yeah, if you want to do do a postdoc and continue, now you're graded on your research, more or less. And I think it's a very different track from yeah, from the support role, this research software engineering role that we're discussing now.
Yeah, it's very interesting because I would just had this conversation a couple episodes ago with Josephine Prol,
Mhm.
who was we also discussed the matter of this H factor or H index that is being used to effectively grade scientists. And inside of it, she made the comment that she would like to see more inclusion of support roles, but in her case it was specifically mentoring, the mentoring of other students, or taking on students, being included somewhere in that consideration or grading. And in your case, in terms of like supporting, in terms of software support, right, helping groups to accelerate their research through fixing their codes, squashing bugs, or whatever, handling other software related issues.
Mhm.
And I'm curious to think, or to ask you, do you think that there is a place for evaluating, or a way to evaluate how much you contribute to a code base, let's say, so that it could be maybe included in such an H index, a reevaluated H index in the future?
And I think it's quite difficult.
Okay.
There are some approaches, for instance, for papers to measure contributions on several different fronts. I'm not sure if you've seen it. I forgot the name, but it's I think they have 9 categories that you can put your own name in on the paper. Like, this is the person who did the funding, this is the person who did development, this was support, data analysis, etc. So to split it out there, but even then, if so that's on a personal level. But if you're using tools which are just available, like maybe you are using Raptor or some other code, um, some of the credit of your paper should go there,
Mhm.
because in the case that it would not be possible without. Like,
Right.
okay, we're all using Python, for instance, for many things, and um, without it would be much more difficult to do some of the work. But we're not going to credit this on every paper, and you're not going
Mhm.
to write a list of all of your Python packages. So I think it's up to the individual scientists to clarify which tools were very useful or especially necessary to do their research.
Yeah, I do know in our when we write papers, especially in the software side, the computational side, we do try to cite all of the specialist codes that are being used to get the result that we're displaying in the paper. Also, times we cite codes that do something similar, right? And we say, okay, there are these other codes which could do the same thing, but we just didn't use it for our paper, in a way to give credit not just to what,
That's nice.
yeah, what we're using, but what other people have developed in tandem,
Mhm.
on their own. But I think that it affects the H index because you get citations, but in the end, is not a very large reward per se, right? It's not like you
No,
directly as the person who developed the code. Maybe the PI, the person who wrote the paper that we're citing, is going to get a fair number of rewards due to the citations. But as someone who just helped to develop that code, I don't think you see much of that, right? So it's it's still a hard problem to solve, even on an individual level, because we don't have the mechanisms.
yeah.
Um,
So what you get instead is that a lot of codes are managed by institutes. Like,
mhm,
maybe Lawrence Livermore is hosting some codes. The HDF5 group develops it, gets funds from governments. So once you get large enough, there is a way to fund important infrastructure. It's just that the path to it is kind of uh, hard or unclear, I would say. And I think it's up to our institutes to fund people who are not only people who are doing important science, but people who are enabling important science. And
mhm.
um, that a package is not only interesting if you can also write uh, computer science papers on it.
Yeah, and I think that also comes to a part where it's particularly interesting that academic people who are end up doing research as a career, are very interested not only in advancing their career, but also tend to have a personality that wants to help the community, and what allows them to go forward and spend a lot of time and effort making these things for other people
Yeah,
effectively. But it's hard with that type of community to put something in that returns to the individual. It usually returns to the body, that the administrative body that has all these individuals in it, but not directly to the individual. So it's a question, I suppose, and we don't have to have the answer. But I was just curious if you had any thoughts on how to do that.
well,
Um,
yeah. I'm not sure how to get some more credit to the individual. I think um, if you get to the more important packages, people will know who the main maintainer is, and
mhm,
you may get approached by companies to work. And I think there are many cases where prolific open source contributors have had a very easy time getting hired. So
right.
um, it's really it's works quite well in that way, I think. And besides that, it doesn't have to be a consideration like, oh, it's my full-time job to open source my code. No, it's more like I spend 5% of my time doing those kind of things. And if everyone does it, then we have a massive force of people writing public code.
That's true. Well, I think that is what academia is in some
Yeah,
sense, right?
yeah. And we have to find the balance between keeping your group advantage, being able to be the first to write your papers on new subjects, and sharing the methods you use, not only the results.
Mhm.
Like this is kind of linked to this reproducibility crisis that has been happening in some fields, and also for us, it's quite hard if you are reviewing a paper with some result from some other code to actually look into what's happening there, especially if it's one which requires significant computing time to reproduce, or which requires tools that you don't have access to.
Yeah, that is a fair point. A lot of my efforts as well in the PhD was benchmarking
Hmm.
because we don't know what was done before or how it was done or what the code is precisely doing, that we have to start making comparisons with other codes where we do know what they're doing just to double check everything. But if everything was open source and clearly, you know, defined in that way, we could spare a lot of overhead doing benchmarking. We just sort of, or at least if there was a standard way to run things,
Hmm.
that
Yeah.
we would be able to do the benchmarking quicker. Like, as you know, there's always versions and all this sort of stuff.
Yeah.
So yeah, I
Well,
think that's
well.
part of the work that's happening now in with these TSVVs, as you said. But
Mhm.
there's room for improvement. I
Well,
agree.
I think ITER is funding some work which might help there.
Mhm.
Um, we are part of the consortium doing it is on uh, standardizing the components in like a coupled simulation with multiple actors, with multiple codes communicating to work together on one simulation to get one result. And this will give you quite a lot of standardization of how to run codes, and also standardization of how to run combined codes. So you'll see some interesting stuff coming out there in the next few months.
And this is stuff you're working on.
Yeah, yeah.
Oh wow. Okay. Cool. Yeah, that would be very interested in learning more. Obviously, I don't know how much you can say if it's
Not
work in
not too much,
progress.
not too much actually, but um, there are some like in the ITER conference pages there are explanations. So
Okay.
this is one of the issues that uh, um, I think will bite ITER again is all the work that is done due to this ITER agreement has to be only accessible to member states. Never mind that this is 80% of the world population or something. This other 20% is not paying, so they shouldn't see it. And
Mhm.
um, the consequence of that means that is that um, all of this work which happens has to go behind a paywall. Well, it's not really a paywall; it's a login wall, and you can get access if you ask the right people. But it's not really open to junior researchers, to people who are interested in fusion for a master's thesis, but are not linked to one of the existing groups. And most importantly, you cannot find the documentation on Google
Mhm.
because
So
it's not public.
yeah, and there would be no way for you to know that such a body of tools exists unless you happen to know the
Exactly,
right person effectively.
exactly. And so to me, this is a drag on our innovation speed as a community.
Okay, yeah, I fully agree. I think that they're definitely, I mean, everybody has their own login wall, as you say. I think I have like 20 passwords, right? Like and then 20 different logins for each European institute. And it's and abroad even as well. So I think it is definitely an issue that needs to be solved at some point, even if it's just one single central login would still already be very nice, right? If you have to put it behind some sort of protective
Mhm.
wall.
Yeah, and
But
a nice
still.
process to get access to,
Mhm.
because like typically the access rules are not that strict. I think any associated institute can get this code, but you have to ask. And so we're working, or we're asking at least if this can be more open, and suggesting that it should be, but it is not up to us.
Okay, fair enough. Well, I mean, I wish you good luck in that endeavor. I would have really appreciated if it is open sourced for sure. And I think, I guess, we're kind of rounding up on our time. So I do want to ask you, do you have any sort of like final opinions or final recommendations for software infusion, right? Like things that you would like to see as you move forward or think are neglected overall as like an over. You can even talk about things we've already talked about.
Oh yeah. So no, actually, I think I'm quite happy with what's happening. I guess there's a whole bunch of very advanced computing happening in Fusion, really pushing the limits on some things. Um, there's there's a whole bunch of things to be very proud of. There's also a bunch of things which we should go faster on. Um, especially our predictive modeling of our Fusion machines is not great yet, and
I agree. That is something that I'm working on as well. Yes.
yeah, well, yeah, exactly. And from what I've seen, you're doing great. You're doing a great job, but I should be much more invested into this field to get to the situation that we can safely run ITER instead of take the risk to break something because we hit a path of the discharge that we haven't foreseen. So we have a lot of work to do, but there's been incredible modeling advances. I think we'll get there. It's just that it's a very interesting and very complicated problem to look at,
Yes.
physics wise and compute wise.
Yes, and it's also a very exciting time because we are starting to become more integrated in terms of not just the codes, but the people involved in it. There's these big frameworks to try and get everyone talking again, rather than being isolated in different institutes around the world. And I think that that will improve as well. It would help significantly.
Yeah,
All right.
yeah, I agree. It's I think we're doing the right things, and let's see if we can get some nice results out of our ITER operation and continue our fusion research. Yeah, get there in time.
Great. Okay, then. So then, with that, thank you very much, Don, for coming on to the podcast today. It was a great conversation about
Thank you.
how the state of software infusion. And for all you listeners out there, just to remind you that the Coffee Breakdown podcast is a place where we want to emphasize the creative and human side of science. And we like you to take into account that not just you are learning, but also us here, myself, and all our guests. And so, with all of that, thank you again for joining us, and we'll see you in the next episode. Bye.